All right, we're back. We're on page 198, and we are still talking about parametric equations for things that move back and forth. And we were talking about distance between those things, and we saw that they have very weird-looking distance formulas that are periodic. The periods of those distance formulas turn out to be the least common multiples of the periods of each of the functions involved. So there's kind of like a lot going on. Let's see if we can answer this question. So a particle moves around a circle, okay, centered at -4, 5, with a radius of 8, beginning at its northernmost point. So, I mean, I'm gonna just kind of like draw something so I can work out what's happening there. Northernmost point, traveling clockwise, which is the opposite of the unit circle, so it's going this way. Okay, so I think I can write that. Let's see. I'm gonna call it x1, y1. So the center is -4, 5. And then the x-coordinate starts in the middle and increases. So that's going to be a positive sign. What does it increase by? So by 8. So +8 sine. The period is 40. So this will be pi over 20t. And then the y-coordinate has to decrease because you're starting at the maximum. So that's going to be -8 cosine pi over 20t. All right. And then we also have a thing moving along a line segment going back and forth. So 8, -6 is like here, and then -8, 20 is like here. So this will be t equals 0. It takes 50 minutes for a round trip. So it's going to get here at t equals 25, and then go back and forth. So it's like this. All right. So what am I doing? All right, so x starts at a maximum and then goes to a minimum. Y starts at a minimum and then goes to a max. Okay, so if x starts at a maximum, it's positive cosine. If y starts at a minimum, it's negative cosine. So we have that. And then I need the midpoint. So when you do these, the midpoint is important because the midpoint becomes the sinusoidal axes of your respective equations that you come up with. So I actually need that. So let me label these. 8, -6. Do you think I say so enough, or should I say it more? So I don't know. Open to interpretation. This is going to be 0. That's convenient. And then 14 divided by 2 is 7. So 0, 7. All right, we can do this. X2, Y2. What am I going to do? I'm going to do. I'm going to put these into the calculator to do the minimum and maximum distance, but then I think I'm going to put them in GeoGebra just to like watch it happen. Maybe potentially. I don't know. All right, so x we said is 0 and 7. X starts at a maximum, so it's positive cosine 8 cosine. Takes 50, so this will be pi over 25t. And then y starts at a minimum, so it's going to be negative cosine. And it's 13. It's one of the bigger amplitudes that I think we've seen. T. All right. I think GeoGebra first and then the Inspire makes sense, because if GeoGebra shows me that everything is wrong, I can abandon ship on this video and come back and just do it again. So let's see. Let's see. It's the fastest way. I don't really know. There's not really like a faster way to get these in, I don't think, or I would be doing it all the time. 20t, 5 minus 8 cosine pi over 20t. 0 to, I should have to go to 40 to get the entire thing. And so that should give me the whole thing. Zoom out slowly. Let's put a point on there and make it move. A of v from 0 to, uh-oh, that looks like I'm starting at the bottom. Oh, I am. That should have been plus. So 0 to, what's the least common multiple of 40 and 50? I think 200, I think. Okay, so this has to become plus because I'm supposed to start at the northernmost point. So that's my bad. I always wonder in the video, did I say the right thing and just do it wrong? Like what's this story? I'm gonna change it in the notes right now. I'll change it in red. So when I go back to the notes, if I go back to the notes, you'll be able to see that. Okay, so One thing that happened there, sliders by default should really just increase, but for some reason they oscillate, and I find that really annoying. But what can you do? Get rid of that, and then, ugh. All right, here we go. Play. Woo! All right, let's do the other one. Curve 8 cosine pi over 25t. And then 7 minus 13 cosine pi over 25 t. This should take 0 to 50. You really only need 0 to 25 though, to see the whole thing, because 0 to 25 is like half of the trip, and then it doubles back on itself. But let's see. Okay, we got it going. So yeah, they get pretty close, it looks like. And then I'm not graphing the distance, so like I don't really know if it's reset there. But this looks good. So now I'm gonna switch over to the Inspire. I'm gonna enter those equations. I'm gonna find the maximum and minimum distances. I was gonna say areas. I was like, what does that even mean? All right, here we go. Menu 3, 4, -4 plus 8 sine of pi over 20 times t, and then 5 plus 8 cosine pi over 20 times t. I think that's like the really big advantage of like looking at something on GeoGebra is like you can see instantly it's just not doing what it's supposed to, so like you know that it's wrong. So I was able to save myself and you a lot of annoyance by doing that. So I recommend it. And I know that like students do not like to take advice. I don't really know why, but I recommend it. Like you should take that advice. So we have this. All right. So this looks good. This is our scenario. And then I'm going to do the same thing I usually do. Go to the calculator page, d of t. I'm going to use vectors, right? So I'm going to do the norm, which is menu 77 of x2 of t, comma, y2 of t, and then minus x1 of t, comma, y1 of t. Okay, so if I just type d of t, it'll show me the function. It's nuts. Look at this. What the heck? I'm not even gonna bother scrolling through it. And I know that like at 0, it'll tell me the distance. At I don't know, 10, it'll show me the distance. I believe that the least, it actually has it built in. The least common multiple of 40 and 50 is 200. So that should be the period of the distance formula. So let's graph it. The reason that's the period, I mean, we talked about in the previous video, is like, so something with a period of 40 is at its initial starting point at 0, 40, 80, 120, 160, 200, and so on. Something with a period of 50 is at its initial starting point at 0, 50, 100, 150, 200. They're both at their initial starting points again at 200, which is the least common multiple. That's why the whole thing starts over again, because it's as if nothing even happened at that point. So let's see, they get really close. Well, from the looks of that. So I know that I only need 0 to 200. So I'm gonna go like -10 to 210, I guess. And -4 to like 20. I don't know how far apart they can possibly, oh, they get farther than 20 apart. Let's go back, let's do, I don't know, 50. Okay, they don't get more than that, so that's good. Maximum distance, all right. So we're looking for the maximum and the minimum. So it struggles, the calculator struggles if you try to like go all the way across. It like gets a little confused and sometimes will jump to like other points. And I don't really know why it's doing that, especially when they're not lower. I mean, that I'm pretty sure is the lowest point that we're gonna find, which is duplicated over here. So the minimum, so I'm gonna write this and then I'll go back to the notes. The minimum distance is 2.076 at t equals 10.497. And then the maximum distance is, I think, probably this, but I'm not like 100% sure. We can like, so it's a little clearer if you have a better window. So 50 is too high. 25 is probably good. Yeah, I think you can see that's definitely higher. If you're not sure, just find both. So I'm gonna find the maximum over here. Right, 23.364. I think that's clearly higher than any others. It's a little weird to, this looks really high. And then where is that? Like, where is that? Where is this? Is that that point? I don't think so. I want to find that maximum. Menu 6, oh my God, no. Menu 6.3. Menu 6.3. Here to here, 23.09. It's just like an optical illusion. I don't really know. So I'm gonna say the maximum distance is 23.364 at t equals 151.755. 151.755. Okay, let's go back to the notes for a second and see. And we're like almost potentially kind of done. I mean, we actually basically are done. Let's go back to the notes and see. I left myself some space, so I wrote down the minimums. I made this change. If you didn't make it, you should definitely do that. The distance, d of t, is x2 minus x1 squared plus y2 minus y1 squared. Okay, and then we were able to do that. I'm not even going to try to draw the distance formula thing. Draw the graph, right? It's too crazy. All right, what if instead of a particle, the object moving around the circle is actually a small circle with a radius of 2? Okay, and then the object moving along the line segment is actually a circle with a radius of 0.5. Both moving objects have their centers on the paths. Do the objects crash? So now what we're saying is that, you know, we have a thing on the circle, which is like, great, good deal. Okay, so we have this, and this has a radius of 2. That's 2. And then we have this, and this sort of inaccurately drawn, but this has a radius of 0.5. And what we're trying to say is, do the objects crash? So I'm going to say, because this distance would be 2 plus 0.5, 2.5. So if the centers are closer than 2.5, which is 2 plus 0.5, then 2.5, the objects crash. And then since the minimum distance is 2.076, which is less than 2.5, they do crash. So this is really interesting. We, like we've been assuming all along that they're like particles. Particles are just like points. It's a really common thing to do. But in this case, they're not just points. They're actually little circles. So I'm going to do that. I'm going to say that I'm going to make a circle that is centered at A with a radius of 2, and another circle that is centered at B with a radius of 0.5. And now let's let it go. And can we find, I want to like find a time. Whoa, there we go. Hold on. Let's rewind. There, I think they're crashing. Oh yeah, you can see it. Disaster. Look at that. They crashed. So they definitely crashed. Another approach, so I mean, that's kind of fun. Another approach is if I go back to the inspire, I could add in the graph of 2.5. And you can see that they're crashing anytime the distance graph is less than or equal to that, which it looks like there's one in here too. Let's do menu. I don't know if it's going to be able to find this. Menu 814 for me is intersection points. Click and then click. Ooh, it found them. So between 90, let's say like basically 90 and 91, and then also, so we actually know like how long they're crashing for. They're crashing on these time intervals. So that's a really interesting question. I like that a lot. I'm gonna go back to the notes so you can like, I don't know, see it or something. And then we are done with this page. I'll be back in the next page to do more. So I will see you there. Yeah, I think you should try to make up more problems like this and see if you can do them. I think they're really neat. But anyway, I'll see you in the next video.